Who's ready to do division of rational expressions? Yeah, let's get it done. You know how this differs from division by normal fractions? Nothing's different, except now we have variables. So if you remember back in the day, when you had 2/3 divided by 1/9, we rewrote it. Nowadays they're calling it KCC, keep, change. What we learned was when you divide by a fraction, you multiply by the reciprocal. You get a flip-flop the second fraction. And that's what we're going to do here. So instead of x squared minus 81 all over the denominator divided by our second fraction, we're going to make this x squared minus 81 over that x squared plus x minus 90. Notice my first fraction staying the same. And we're going to make that times, and then we're going to flip-flop or take the reciprocal, and it becomes x plus 10 all over 5x. Remember, we can't cross out the x's, we can't cross out the 10 and the 5, we can't get rid of the x squared. All of these things are in relationships. We can't break them up. You can't act like you're single when you're not. But what we can do is try to do some factoring. We need to factor top and bottom and everything. So if I look at x squared minus 81, and I'm going to use the bottoms up method. A is going to be 1. B, which is supposed to be on our middle term, our x to the first is not there, so that's a 0. And C is going to be negative 81. We're looking for a product of A times C, which is 1 times negative 81, which is negative 81. And we're looking for a sum of 0, B. Remember, whenever you have sumo, that's one of those tricks. This is perfect squares. Okay, so if you take the square root of 81 without the negative on it, in your calculator, you get 9. That means that 9 times 9 gets us 81. It also means that 9 times negative 9 gets us a negative 81. And when we add negative 9 and 9, we get 0. So we found the numbers we want. We would get x plus 9 times x minus 9. Since we're doing bottoms up method, remember that you would divide by a. But that doesn't get us anywhere because both those 9s divided by 1 still get us back to 9. So our first numerator is going to factor into x plus 9 times x minus 9. I'm going to write down my second fraction, and then we will factor our first denominator. So we have x squared plus x minus 90, and we need to factor this guy out so we can simplify everything. Here, a is 1, leading coefficient, b is 1, and c is negative 90. We're looking for a product of a times c, which is 1 times negative 90, which is negative 90, and a sum of 1. So you need to think to yourself, what multiplies to be negative 90 and adds to be 1? So I'm going to use 10 and negative 9 because 10 times negative 9 gets me to negative 90, and 10 plus negative 9 gets me to a positive 1. Writing my factors since I found the magic numbers, I have x plus 10 because the 10's positive, x minus 9 because the 9 is negative. I need to divide by the leading coefficient, which in this case was a of 1, which means that it didn't really change. I'm going to have x plus 10 times x minus 9, which is now my new denominator in my first fraction, my first rational expression. Now that I have everything factored, because we already said we couldn't factor the second fraction, let's go ahead and take a chopping block to it. Anything that shows up in top and bottom of a fraction can go away. Notice that my x minus 9s are ready to go to the party. X plus 10 as a group shows up in the bottom of the first, top of the second. So that's gone. Let's regroup. Let's see what we got going on. We have x plus 9 left up top, and in the bottom, we have 5 over x. Remember that we cannot take these x's apart. We can't take those out. The top one's in a relationship, although the bottom one is single. And because there's nothing else that can be simplified, we have our final simplified answer of x plus 9 all over 5x.